Hello everyone, and thank you so much for being here today. My name is Pinar Arpaçay, and I'm delighted to join you at the Science Fest National Final. Today, I want to take you on a short journey through science, not just the experiments, the labs, or the equipment, but the skills that make science work. So these skills open many different career paths, both inside and outside the lab. And more importantly, they help connect scientific work with society. So our journey today is called From Research to Society, Skills that Shape a Scientist's Journey. First, a little bit about myself. I grew up in Turkey and later studied and worked as a scientist at different organizations in Ireland, Saudi Arabia, and Germany. I completed my PhD in the School of Physics at Trinity College Dublin. For 12 years, I work in research across physics, chemistry, nanotechnology, and biomedical science. I also taught in higher education and STEAM education. Today, I work as a project and education program manager in the field of energy storage at Karlsruhe Institute of Technology, shortly KIT, in Germany. Alongside my job, I am doing my master's degree in science communication at the University of Trento. So, after moving between countries, universities, and very different fields, one thing became very clear to me. Being a scientist isn't about specializing in only one area. Actually, it is about developing a set of skills that you carry with you wherever you go. These 4 skills, research, writing, project management, and communication, shaped my entire journey. Research helped me to explore and test ideas. Writing allowed me to turn results into clear stories that others could understand. Project management kept my work organized, especially when juggling experiments, deadlines, and teams. And communication helped me connect with people, students, teachers, industry partners, other scientists, engineers, and the public. And the truth is, many of you are already using these skills in your school projects, in teamwork, and here at Science Fest. So now, let's look at each of these skills a little bit more closely. So, when you search the word scientist on Google, you usually see these similar images: lab coats, Googles, test tubes, and microscopes. And yes, some scientists work exactly like that. But today, scientists work in many different places. Some scientists never step into a laboratory at all. Others spend most of their time analyzing data, designing software, managing projects, or communicating science to the public. So there are mainly 3 types of scientists. Experimental scientists test ideas in the lab or out in the field. For example, they can grow cells in a lab. Theoretical scientists use maths and concepts to explain how things work. For example, predicting how planets move. Computational scientists use computers to work with big data or run simulations. For example, analyzing climate data. So research is a skill, and its core about solving problems, But today's challenges like climate change, health, or new technologies may require more than one subject. That's why researchers from different fields work together in different ways. Multidisciplinary research means people from different subjects work on the same project, but each stays in their own area. What I mean, for example, a biologist studies plants, a chemist studies soil, and an engineer designs tools, all for the same project. They work in the same project, but separately. Interdisciplinary research. It means subjects start to mix. For example, a chemist and biologist work together to create a new medicine. Their ideas overlap and they solve the problem together. On the other hand, in transdisciplinary research, knowledge from different disciplines come together and works not only within science, but also with society. For example, scientists, doctors, and local communities working together to improve air quality in a city. We often think research is only about experiments, but scientists do many other tasks that are just as important in reality. First, they do a literature review. This means reading scientific papers to understand what has been already discovered. So they don't need to start from zero. Secondly, they do data analysis. After running an experiment or collecting information, scientists examine the results to find patterns and then make conclusions. And finally, collaboration. Scientists rarely work alone. They share ideas, discuss results, and solve problems together. This teamwork helps science move forward faster and with stronger results. So, research is not just a lab work. It's reading, analyzing, and also working together. So writing skill is a very important part of being a scientist. So scientists write all the time, almost. Not just at the end of a project, but every single day. They write lab notes to record what they did, what worked, and what didn't. These notes help them repeat experiments and understand their results. They write project reports to explain progress to their teams, supervisors, or industry partners and collaborators. They write research papers to share their findings with the scientific community, so others can learn from their work also. And additionally, they write many other materials, such as presentations or emails. Another important type of writing scientists do is funding proposal. Research often requires money for equipment, materials, conferences. So to receive this support, scientists must write proposals that explain their idea, why it matters, and how they will carry out this work. A good proposal includes the research question, the objectives, the methods, the timeline, and the budget. It's like building a convincing plan that shows this project is worth supporting. Writing proposals also create opportunities around the world. Many scientists travel internationally as visiting researchers, joining new labs, learning new techniques, and meeting people from different cultures. I also had these experiences during my career, and they helped me grow both as a scientist and also as a person. So Writing isn't only about sharing results. It can open doors to new places and new opportunities. Here is a very familiar example for many of you, I guess, the Science Fest project entry form. So this is also a form of scientific writing. When you, your school, or your teacher fill this form, you are already practicing skills that real scientists use. You write your project title, explain your research question, describe your methods, and outline any work you have already done. You also think about safety, materials, and who you might need to contact for support. In other words, you are creating a small version of a research proposal. You are learning how to plan a project, communicate your idea clearly, and show why your work matters. So even at a school level, you are already using the same writing skills that scientists use in universities, laboratories, research centers, or companies. There's another important skill scientists use, and that's the project management. So research is a project, and scientists are essentially project managers, especially during their PhD. A PhD is the highest academic degree you can earn, and it means becoming an expert in a topic by completing a long, independent research project. During a PhD, you learn how to plan your work, organize tasks, solve problems, manage time, and to keep a project moving, just like a professional project manager. Scientists manage many things at the same time: time, quality, resources, equipment, collaborators, deadlines, and even the budgets. So behind every experiment or research paper, there's a lot of planning and coordination. And these skills open many career paths. For example, scientific project management, managing research projects in universities or laboratories. Education and training programs, running workshops, courses, or students program. Innovation teams in industry, helping companies develop new products or new technologies. Policy or science communication, so advising decision makers or communicating science to the public. So if you enjoy organizing steps, planning tasks, or leading teamwork, you are already practicing one of the core skills scientists use every day: project management. Here is an example of what project management looks like in a real research project. Let's imagine you are running a laboratory project to test a new material that improves CO2, carbon dioxide conversion. First, you define the goal, what exactly you want to achieve. Then you plan the steps: ordering chemicals, booking instruments, scheduling experiment days, and finding collaborators who can support you with analysis. Next comes managing resources and time. Maybe you have limited funding, so you need to choose cost-efficient materials. Maybe the instrument you need is busy, so you have to share it with other groups, other teams. And of course, you follow a tight experimental timeline. So after planning, you execute the plan, preparing samples, running experiments, collecting measurements, and adjusting when something goes wrong. Because in research, things often fail before they work, actually. Then you analyze results and report by processing the data, writing summaries, and sharing findings with collaborators. Finally, you deliver outcomes. This could mean contributing to a publication, preparing a proposal for the next stage of the project, or presenting your results to the scientific community. So even one research project includes goal setting, planning, teamwork, problem solving, and communication, all the key parts of project management. Now, let's look at another key skill, communication. Science communication. It is all about sharing scientific ideas in a way that people can understand and connect with. It helps increase awareness about important science-related topics and creates a bridge between science and society. And the target group is broad: students, teachers, general public, decision makers, and so on. For example, science communication is the reason I am here with you today. The goal is, for science communication, it's simple: make science clear, engaging, and useful for everyone. So, why do scientists communicate in the first place? Scientists communicate to share new findings, to explain why their work matters, to inspire younger generations, and to make sure the information people receive is accurate and trustworthy. And there are many ways they do this. They might give talks at schools, festivals, or conferences. They write articles, blogs, or short summaries of their research. And also podcasting. They create visuals, videos, or hands-on demonstrations to make ideas easier to understand. And they often work with different teams, such as designers, educators, or journalists. They communicate with decision makers to help guide policies. So why is all of this important? Good communication helps people understand scientific ideas that might seem complicated at first. It also builds trust between science and society, which is extremely important today. It encourages young people, like many of you, to consider STEM careers. And overall, it makes science more engaging, clear, and accessible to everyone. Now, let's zoom out a little and also look at the future. These are the top growing skills by 2030. AI and big data, artificial intelligence, networks, cybersecurity, and technological literacy are becoming essential as technology develops faster than ever. Creative thinking and analytical skills are about solving problems in new and smart ways, something you practice in every science project. Resilience, flexibility, and curiosity are skills you build naturally when experiments fail or when you try something new. Leadership, teamwork, and talent management show how important it is to work well with others and guide the project forward. And finally, environmental stewardship reminds us that many future careers will focus on protecting our planet. So whether you choose science or any other field, these skills will help you succeed in the jobs of the future. And good news, you are already developing many of them today. I want to show you a fun example of how science and skills shape the future. a neighborhood grid broker. It sounds imaginative, but it's actually based on real trends. Imagine it's the year 2050, and neighbors around the world produce so much renewable energy that every home becomes both a power station and a mini marketplace. In this future scenario, every surface produces energy. Your jacket charges your phone, your window power your laptop. Even the pavement generates energy when you walk. Energy becomes cheap and abundant, but the old grid, old electrical systems cannot handle it. With all this extra energy, a new challenge appears. How do neighbors share, trade, and manage their electricity fairly? And this is where a future job might emerge: neighborhood energy broker. This person helps communities manage their local energy system by combining different skills. All skills we already know: understanding electrical systems, working with communities, basic coding, financial modeling. New skills for the future: microgrid architecture, building small, independent local energy networks. Energy democracy design, helping communities run their own shared power system. Peer-to-peer energy trading, using digital tools so neighbors can buy and sell energy directly. Why this matters? This fictional example shows how the careers of 2050 will mix science, creativity, technology, and also social skills. Some of tomorrow's jobs don't exist yet, and you might be the one who creates them. It shows that the skills you develop today can shape the world of you live in tomorrow, actually. So, you can learn many skills in life, and you already are. But there is one thing that truly sets you apart from everyone else: passion. Think about the scientists you actually know by name. Why do you remember them? Why do a few become world-known while thousands of others remain unknown? It is not just their skills. It is their passion, their curiosity, and also their courage. Many of them dared to imagine the impossible. They weren't afraid of crazy ideas. In fact, they chased them. They kept going even when things failed, even when others didn't believe in them. Skills get you started, but passion is what takes you further. And in the end, the strongest skill you can ever have is simply loving what you do. This is the end of our journey today. Thank you so much for listening. I hope you enjoyed it and learned something new. If you have any questions, you can always email me. Bye-bye.